Hi, hello everyone. So today will be a new video about how to solve. And this time around will be a question that I found online again. So this is the question that we'll be tackling today. Okay, so the question is, okay, you are asked to solve this equation. All right, basically you have x plus x over 1 plus 2 plus x over 1 plus 2 plus 3 so on and so forth until the last term of x over 1 plus 2 plus 3 all the way to 99. And this whole equation equals to 99. So what is x? So in order to solve this question, when I first saw it, okay, this question is, when I look at what is happening here, the denominator, I can see that every term itself is an arithmetical series. So but this time around, when we look at this whole thing, right, it is actually in a form of what we call a harmonic arithmetical series. So how are we going to deal with this harmonic series? Okay, and this is how I solve the question. Okay, let's illustrate the equation again. Okay, so I just put it here. Next term is actually I factorize out all the x. So when I factorize it, x will be on one side. Everything inside, okay, all the numerators will be 1. So you can actually see straight away, okay, the arithmetical series. Okay, sorry, the harmonic arithmetical series. So if we remember from arithmetical series, okay, the sum for any n term, if given as if it's being identified as what we call an arithmetical series, it can be expressed as this form. N represents the number of terms, A represents the first term, D represents the common difference between them. Okay, so for any value of n, okay, this is how you find the sum. Okay, but please take note, this is, okay, just the arithmetical series. It is not the harmonic series. Okay, so we have to establish this first. So if we look at the series over here inside, we know that the first term, okay, the very first one, because it's 1 over 1, the first term will be 1. So A in this case is 1. And of course, the common difference, if you look at all these arithmetical series, their common difference is also 1. Okay, that means, like, for example, 3 minus 2 is 1, 2 minus 1 is 1, so on and so forth. Okay, so in this case, okay, the arithmetical series will be, if I'm going to rewrite this, okay, it will be 2n plus n of n minus 1 of over 2. Okay, I hope you can see what I meant here. I'm just going to expand this in and replace a and d as 1. So now, since we are dealing with harmonic series, so in this case, notice that over here, denominators, they are actually what we call the arithmetical series. So 1 over the arithmetical series is 1 over Sn. Okay, I hope you can see what am I trying to do. Okay, so this represents each of these term over here. Each of these term, so on and so forth. So 1 over Sn will be equals to 2 over 2n plus n times n minus 1. Okay, I hope you can see what's going on. I just reciprocal both sides. Okay. So at this step, the next step, okay, what is going to happen is now we are going to look at the whole series altogether. So in this case, 1 over Sn is each term. So each term represents by this expression over here. So now I'm going to introduce the sigma or the summation notation. So this whole series here is actually trying to tell us is the sum from n is equals to 1 all the way to 99. And there are 99 terms in between. By the way, there are 99 terms. Okay, all the way to 99 of 1 over Sn, okay, is equals, if I'm going to take sum over here, I'm going to take the sum over here. So if I'm going to take the summation over here, all right, 2 is a constant, so I can actually factor out 2, the constant 2 over here. All right, and it's the sum from n is equals to 1 to 99 of 1 over 2n plus n of n minus 1. Okay, I hope you can see what's going on here. So if that's the case, okay, I just clear up the equation a bit. Okay, I can just factor out n, and inside you have 2 plus n minus 1. So by clearing up for even further, I have 2 of the sum from n equals to 1 to 99 of 1 over n of n plus 1. Actually, you can come straight away to this step, okay? Because the arithmetical series over here, all the way, everything below, okay, they have a common difference of 1, and the first term is 1. So it is basically like how you do a very basic calculation from 1 to 100. The sum of 1 to 100, we know is 5050. Okay, but basically by applying this expression, n of n plus 1 over 2. Okay, but since this is a harmonic series, it is the reciprocal. So 2 over n of n plus 1. Okay, so this can be actually pretty much straightforward lah. I just actually show you all these steps, okay, is based on how a general term, okay, a general arithmetical series is able to transform its way here. All right, so the next step, okay, if we look over here, now 1 over n of n plus 1. Okay, if you know there's an identity, we can actually transform this into what we call, okay, a partial fraction. So in this case, all right, the whole fraction over here will be split into 1 over n minus 1 over n plus 1. How do I know that? Okay, I can just cross it, all right? And you can see that this minus this, you'll get back 1 over n times of n plus 1. Okay, and 2 is 2. Okay, so what is the purpose of doing this? Okay, if you know a college method, it's called the telescoping series. How are we going to apply telescoping series? By reduction, okay, the sum and differences to get a converging value. So in this case, now I'm going to write this over, okay, the identity that we have obtained just now. Now, if you're going to sum for any finite sum from n is 1 to any value of n, capital N, I just use it as capital N. Okay, you can see over here, all right, if this is the first term is definitely 1 minus half, okay, and the next term is half minus a third minus a quarter. So you can see what's going on over here, all right, and then the n minus 1 term is 1 over n minus 1 minus 1 over n. And likewise, the last term, the n term is 1 over n minus, okay, 1 over n plus 1. Okay, so this is basically what I call a telescoping series. So from the telescoping series, you can see that half and minus half, it can be cancelled off. Minus a third and a third can be gone. Minus 1 quarter and a quarter can be gone. And everything in between can be cancelled off. All right, because you have one sum and one minus. So they can actually cancel off each other. Now, what is the only terms that is left? The first term, the 1 over here, okay, because there's nothing to cancel it away, so 1 remains, and minus 1 over n plus 1 will remain, and everything will be gone in between. So that is basically a telescoping series. Bam, and that is what we got over here. Okay, so this whole series here will converge at 1 minus 1 over n plus 1. Okay, this is pretty simple and straightforward. So now I just write down what we have just now. So just now, for the finite sum, okay, from n equals to 1 to 99, okay, of 1 over n minus 1 over n plus 1, okay, we can use this substitution, okay, we can substitute this result inside. So what do we get? If we substitute this in, now the n term in this case is 99. So n is 99, 2 is over here. Okay, so you have 1 minus 1 over 99 plus 1. So 99 plus 1 is 100. Okay, so this is how I get this expression over here. Now, Okay, so very simple. If I evaluate this, I get 99 over 50. All right. So remember just now that is the equation that we are asked to solve, right? Okay, so I took x out. Now notice everything in between, okay, over here, this huge sum, okay, can be converged. Okay, it can converge at 99 over 50. So I just replace 99 over 50 with everything down here, everything over here. Thus, very simple now, it will be 99 over 50 of x equals to 99. So, nevertheless, x is 50. All right, and that is the answer to the solution. All right, so anyway, for this question, I actually found it, just a minute. Actually, I found it over here. Okay, so that was the maths question that came out. Now, everyone, I would say most of them they get 50 as well. Okay, so some of them they actually gave a different solution. Okay, but at least the one that I shown just now is the one that I actually attempted to prove. Okay, so yeah, these are all the response to it. Okay. All right, so that is the question for today, and thanks for watching. All right, tomorrow got class. Okay, so good night. See ya. Until next time. Bye.